North and Central America for the Urethane Systems division within LANXESS. I would like to start this meeting today just giving you some quick tips on how to improve your experience with this WebEx meeting today. So number one, please try to disconnect other programs that may decrease the load of your Wi-Fi network. So also try to mute yourself. And if you have questions, please make sure to send them, to write them down in the chat at the WebEx. And we're going to be reading them to Ian in the end of the presentation. Well, I'd like to take the first 3 minutes of this presentation to give you a brief introduction on LANXESS and the Urethane Systems business unit. So LANXESS was created in 2004 as a spin-off of Bayer. LANXESS is a truly global specialty chemical company present in 33 countries and with more than 14,000 employees. Our global revenue is in the range of 7 billion euro. LANXESS has 10 different business units divided in 4 main segments. The Urethane Systems business unit is a standalone business unit situated within the engineering materials segment. I'd like to now go a little bit deeper in the LANXESS Urethane Systems business unit. So we are a truly global business unit, and we have 6 production plants, 7 application development centers, and 1 world-class R&D center here in Connecticut, USA. We have more than 500 products in our portfolio, over 250 million euros in sales, and around 400 employees globally. We are the market leaders for hot cast elastomers with over 60 years of experience in this technology and industry. And as you may know, we are also the market leader for the low-free isocyanate technology. This next slide shows you how truly global is our 2 production plants and an R&D center in USA, application development center in Brazil. We have 2 plants in Europe with 2 application development centers in UK and Latina, and our global headquarters is in Cologne, Germany. We also have an application development center in Mumbai, India, and 1 in Sydney, Australia. We also have a plant and an application development center in China. Our products are divided in 4 main groups, where elastomers is the main one, and tires and wheels is one of the main applications within the elastomers group. We also have products for coatings, adhesives and sealants, and polyester polyols. Well, with that being said, I would like to now give the floor to my friend and colleague, Ian Laskowitz. He's a member of our technical team within LANXESS for more than 14 years. He's a plastics engineer, and he's pretty much a specialist in tires and wheels. His work is related to product development, mold development, troubleshooting, and finite element analysis. Well, with that being said, have fun. Ian, the floor is yours.
Thank you for the introduction, Bruno, and we'll dive right into the low rolling resistance technology here. So when it comes to tires and wheels, there's many applications, and across the applications, the big things that are important are reduced downtime, and what we're trying to do is elaborate that now to low rolling resistance or energy savings. When you talk about these industries, we talk about material handling, roller coasters, robotics, push carts in hospitals, and many different applications where that rolling resistance does become important. So here at LANXESS, what we try to do is we try to look at the actual end requirement and correlate that back to a material property. So you can see here in the middle table here, we talk about actual end use demand or needs, longer life, loads and speeds, flat spotting, energy savings. And what we try to do is correlate that back to the actual engineering property, not a data sheet property for most of the time, but an actual engineering property. And how do we obtain that engineering property? So for instance, when we look at lifetime, one of the things that's of interest is fatigue resistance. And we can relate that back to different fatigue tests. There's tensile fatigue test, and in our case, one of the ones we rely on heavily is Texas Flex. We also, in terms of lifetime, look at hydrolysis. Hydrolysis is the effect of moisture attacking the urethane and degrading the urethane. We look at abrasion resistance. We want to look at the load and speed capabilities of a material. In that case, we'll look at dynamics. We'll look at flat spotting as well. So you have two types of flat spotting, whether or not you want to look at creep or stress relaxation, or just in terms of dynamics frozen in that can be rolled out. So we look at the hysteresis curves and the modulus curves on those. Those can also be related to the dynamics can also be related to rolling resistance. And we'll talk a little bit about that. And you can see there's other ones as well. There's the no noise and the non-marking. And again, we try to correlate those as best we can back to an engineering property. In the industry today, most materials for wheels are rubber or urethanes. And in this case, we're going to compare a standard rubber with our one of our high-end urethanes with a focus on rolling resistance. So when you're looking at the two categories, rubber, the main benefits of rubber that we see a lot of is improved wet traction. If you need very good wet traction, rubber is usually the way to go. If you're looking for the lowest cost initial investment, the rubber is the way to go. With urethanes, if you're looking for that lower rolling resistance or that improved dynamic, that in dynamics that increased load capability, urethanes are the way to go. And generally, urethanes have improved abrasion resistance when you talk to at a similar hardness. So in this case, on the right-hand side, we're looking at the two materials. Again, a standard 75 Shore rubber with a one of our high-end new developed 75 Shore urethanes. The red bar is the actual rolling resistance. So in this case, lower rolling resistance means less force to roll the wheel, so lower is better. The gray bar is actual load capacity at 10 miles an hour. So in that case, higher load capacity is what we're looking for. And in this case, what you can see is the urethane is roughly 3 times improvement in terms of rolling resistance. And this is per wheel for the specific application that we were looking at. And the load capacity is significantly higher at 10 miles an hour. Again, same hardness, 75 Shore for both of these. So again, that significant drop in rolling resistance is what we're really interested in here, is where we're really trying to understand that technology better and give that benefit to the customers for the end savings. So when we look at urethanes, we saw the improvement of the urethane for rolling resistance, but when we look at urethanes, we can break it down into essentially 3 types of urethanes. We have on the left-hand side, the polyether. On the center, we have the polycaprolactone, and on the right, we have the ester. Each of those has their pros and their cons. When we look at an ether, ethers generally have excellent low rolling resistance. They generally have excellent dynamics, which is load carrying capability, and they have zero concern with hydrolysis. If you recall what I mentioned earlier, hydrolysis is the effect of moisture attacking that urethane. Usually what an ether gives up, it gives up that cut and tear and that fatigue. If you move to the center, we look at a polycaprolactone, which is a type of ester. Basically, it's a high-end ester, and it gives you good rolling resistance. Not quite as good usually as the ether. It gives you very good dynamics. Again, not quite as good as the ethers generally, but it does give you that extra cut and tear and that extra fatigue. Where it falls a little bit short is it is prone to hydrolysis, not quite as much as the ester, which I'll talk about next. And then again, usually gives you a little bit reduced load capacity versus an ether. On the right-hand side here, we have the ester. It has very good cut and tear, very good fatigue. Usually it gives up the dynamics versus the ether and then also the PCL. But where its major concern is with hydrolysis. If you're looking at an application in a hot, humid environment and you're looking for over a year, an ester is definitely not the right choice due to the hydrolysis breaking down that ester material. And then generally, it has reduced load capacity versus an ether and a PCL.
Ian, we have a question our host has passed along regarding the rolling resistance versus rubber, and whether that means the battery life would be twice as long with the urethane as with the rubber.
So for those of you that couldn't hear, the question is, does the urethane have, with the lower rolling resistance, give you twice as much energy savings, being significantly lower? And it's a good question, and it has more to do with the whole dynamics of the whole system. So it's not going to, it would be a cost reduction, but it wouldn't be half, or it would be application specific. So we'd have to look at every applications. We'd have to look at energy efficiencies of the efficiencies of the engine and losses throughout the system. So again, it would be a reduction, that force, but it depends again on the specific application. So moving on to the next slide, looking at the different materials, I'm comparing actual specific materials. So on the left-hand side, we have Vibrathane 8030. That's our polycaprolactone that we discussed. In the center, I have Vibrathane 23708, which is a standard conventional ether. And on the right-hand side is an LFM material that's newly developed, and that's an ether, but it actually bridges the gap with the deficiencies. So when we're over, I'm going to talk right now about the Vibrathane 8030. Again, that's the left-hand chart. That's the polycaprolactone. If you recall, polycaprolactones generally are the bridge between the ether and the ester. There is a little bit of hydrolysis concerns with polycaprolactones, but what it does give you is it gives you that good toughness, that good tear strength, and decent fatigue. When you move to the center one, that's the ether again, the conventional ether. And what you'll notice is about midway down on that chart, you'll see that tear strength. On the left, the 8030 was 120 PLI, pounds per linear inch. The center, that 23708, drops significantly down to 25. So you're really giving up that tear strength. And again, the fatigue goes down with that. But you gain that hydrolysis. Over on the right-hand side is the Adiprene LFM E320. So again, that's an ether, but what that ether does is that's this newly designed ether, which actually generates provides a higher tear strength. So it bridges that gap. So it's over 3 times more tear strength than the conventional ether. It's the best out of all 3 of the materials in terms of fatigue. Actually, the LFMs have best-in-class fatigue strength and phenomenal abrasion resistance. So what we have here is we have 3 different solutions that provide low rolling resistance, but yet they all have their differences in terms of pros and cons, whereas the LFM actually, again, combines those 2, bridges that gap a little bit between the ester or the polycaprolactone and the ether. So when we move to the next slide here, we actually have, we're talking a little bit about the low rolling resistance as well as the load capability of these materials versus a urethane industry standard. So if you look at the left-hand side, what we do have is the wheel geometry that was used in this calculation, as well as the load applied. If you look at the middle chart, we're looking again comparing an industry standard in terms of rolling resistance and load capability. Again, the red bar is the rolling resistance, lower being better or less resistance. And then the gray charts, the gray bars are the actual capacity at 10 miles an hour. So again, the industry standard has very good load capability and a significantly higher rolling resistance compared to these special urethanes or these low rolling resistance urethanes. The Vibrathane 8030 has a rolling resistance of 4 compared to 9, so we're cutting that about in half. Again, that was the polycaprolactone. We do drop a little bit of the capacity there, but again, over that 500 requirement. I think we have one more question.
Yes, we do. Ian, is lifetime of a wheel affected more by the cut and tear properties or by the fatigue properties?
So another good question. The comment here, I'll go back to this chart, is the lifetime of a wheel impacted more by the fatigue resistance or the cut and tear? And it would depend on application. So for instance, a wheel that's a a torque wheel, a drive wheel, or a brake wheel generally will be more driven in terms of lifetime by fatigue. If it's an idler wheel that is, or a drive wheel that's going over lots of debris, contamination, dock plates, if it's run outside, a lot of times it's that cut and tear. So on a dirty floor or with a lot of debris, the cut and tear usually is the main culprit for failure. And then if it's more of a drive or a torque wheel, we look at fatigue there. So going back to this slide here, we were talking about the load capability of the different materials. Again, the industry standard on the left-hand side of this bar is a good urethane wheel. This actually is in this particular case is an ether, but it's not focused on low rolling resistance. So it has a 9-pound per wheel rolling resistance. Whereas if you move to the 8030, which is the polycaprolactone, which is focused on low rolling resistance, it drops that about in half. If we look at purely the ether, the next one over, gets a little bit better rolling resistance, similar load capability to the polycaprolactone. And then when we look over to the right-hand side here, the adiprene LFM E320, again, this was the material that combines and bridges that gap between the ester or the caprolactone and the ether. And what you see here is significantly higher load capability and very good rolling resistance compared to the industry standard. And just for comment, all of these materials are roughly 75 to 80 short A in terms of the hardness comparing these. So there isn't a huge difference in hardness. Actually, the highest hardness one here is at 80-30, being at 80 short A. The rest of them are at 75 A. So what I'd like to talk about next is our proprietary wheel model. We in-house have a wheel model that's developed to predict end use. So basically what we do is we look at the material properties and then we input it into our wheel model and we can predict hysteresis failures in different applications. We also can look at fatigue failures and bond failures as well with this wheel model. So the basis behind this wheel model is our dynamic mechanical analysis, or DMA. I'm not going to talk too much about it on this slide. I just want to give a brief overview. We actually have presentations, full presentations that talk about this dynamic mechanical analysis. But basically what we can do is we can take a specimen size about the size of an index finger, and we can generate all the engineering data required to accurately predict failure. So what we look at is we look at energy stored and energy lost and the change in modulus versus temperature as the wheel works. Here's an example of kind of what we need and where we go with our wheel model. So from the LANXESS standpoint, we are the application development group, and the material side over on the left-hand side, what we do is we generate the data from DMA with the critical temperature, the modulus versus temperature, and we look at the tan delta. And tan delta is the relationship of energy stored versus energy lost. Our customers provide us usually with the geometry, the outside diameter, the inside diameter, the width, what's the profile of the wheel, and what's the profile that we're riding on. Are we riding on a rail? Are we riding, for instance, like a roller coaster, or are we riding on a flat surface, for instance, a forklift in a application in a warehouse? We also look at ambient temperatures, and we look at the loads and speeds. And then what we generally output is we could output the load and speed based on the geometry and the material, and we also look at fatigue and bonding. So the load and speed is usually a hysteretic failure. When is it going to actually internally melt down? When is it going to blow out? We can find that threshold fairly accurately. So in terms of accuracy, we have very high accuracy in our wheel model. If you look on the left-hand side here, we're basically, the black bar chart is the failure speed of an actual dyno and on the dynamometer. And then on the right-hand side, the red chart, it's the actual predicted failure speed based on our wheel model. And in this case, you can see the actual loads the actual actual speed was 18 miles an hour and the predicted was 17.5 miles an hour. So you can see about a 97% accuracy. Over on the right-hand side, we did this with many different materials, different hardnesses, different chemistries. And what you're able to see is the correlation between the predicted and the real world. So very high accuracy on our theoretical wheel model. And we run many of these throughout the year for many of our customers. So it's been used for quite a few years, and we have quite a bit of history on using this. With that, I'll throw a couple conclusions out here. I just want to recap that we are a systems provider that we have many different solutions out there, many different chemistries, and we can focus on different needs of the customer. In this particular case, we're looking at load capability and rolling resistance, that relationship between those two, and how can we possibly save some money or some energy savings with the lower rolling resistance while maintaining the loads needed for the capacity versus different materials, and in this particular case, rubber and other urethanes. We do have a broad range of urethane technologies to achieve desirable performance. In this case, we just highlighted on 3 at that 75 Shore mark with very good rolling resistance and load capabilities. And then the last comment is our technical team, we combine the chemistry know-how or the chemical know-how as well as the material properties and engineering know-how. And that synergy is what we like to provide to our customers for a solution. And a perfect example of that is our proprietary wheel model. So with that, I will open it up for any questions. If you want to use the Q&A feature, if there's any additional questions beyond the 2 that we had, please feel free to ask those in the Q&A section.
I see there's a question as to whether we can get a PDF copy of your presentation.
So the question is, can we obtain a PDF copy of the presentation? If you want to send an email to any of the hosts or myself, we can follow up with you on that. Any other questions? All right, I think that's it. I appreciate everyone's time. Thank you. If you have any questions, please feel free to reach out to any of us on the team here. You have Bruno, myself, and the invitee as well.
What's the advantage of a tapered edge versus a square edge design for a wheel?
Oh, we do have one more question. So the question is, what's the advantage of a tapered edge versus a square edge design? So I can probably talk a while about it. I'll try not to ramble on too much. In regards to a taper, usually what happens with the taper is you're reducing your effective width of a tire. So some benefits of that could possibly be less scrubbing during turning, so easier to turn. However, again, you're probably going to reduce your load capability as you're narrowing down your actual riding width. A lot of times what we'll see is a crown on a wheel as well. That will help with the turnability or the scrubbing. And then there's also some different designs out there with dual casters and things of that nature that can help with turnability. But again, it depends. Our wheel model actually is able to predict load capabilities on a straight wheel, tapered wheel, crown wheel. So we can look at all of those advantages or disadvantages based on that. Any other questions? Well, again, thank you. I appreciate everyone's time. And again, if you have any questions, please feel free to email myself and we can try to help you out in any way possible. Thank you.